Now, in the first part of equilibrium, we've seen how concentration affects an equilibrium mixture. Now we're going to see how pressure affects an equilibrium mixture. But you have to be careful that pressure applies only for gases. It does not apply for solid or liquid, only for gases. So when you're using this reasoning, you have to ensure that all substances that you are taken into consideration are gases. So you'll see in all my examples, I'm referring only to gases. So gas, and gas. Here I'm not going to consider the water because it's going to be liquid here. So it's only for gases. Now, when we talk about pressure of a gas, the more moles of gas you have, the more pressure you have. So for example, if I have let's not talk about moles. Let's say I have 3 particles of nitrogen gas, and then I have 1 particle of nitrogen gas. Okay, so I'll see. So nitrogen exists as diatomic N2. So 3 particles of nitrogen, 3 molecules of nitrogen, and then there's 1 molecule of nitrogen in that same container. So which one will exert more pressure? So remember, pressure is force per unit area. So we have more collisions per unit area compared to here. So pressure here is going to be high. Pressure here is going to be low. So when you're looking at these equations, the numbers in front here will always going to tell you how much gas there is. These actually tell you the number of moles of gas. We'll study that in the next unit. But for now, just use these numbers in front, the numbers, the stoichiometric ratio, to indicate you how much gas you have. So if I take the first example on the reactant side, so I have 2 gases, 2 molecules of sulfur dioxide, and I have 1 molecule of oxygen. Okay, and on the product side, I have 2 molecules of sulfur trioxide. So if I compare the pressure on the reactant side here, what's the pressure? So 2 plus 1, so there's 3 particles, so which means that we have high pressure here. Okay, and if I look at the product side, I have only 2 particles, which means I have low pressure. Okay, now what are we doing? So if pressure of the system is increased, so if we increase the pressure, what will the system want to do? So the equilibrium is going to shift to decrease the pressure. Okay, so equilibrium will shift to decrease the pressure. So in which direction is it going to shift? Will shift in this reaction. We are increasing pressure. Equilibrium will shift to decrease pressure. So equilibrium is going to shift to the right. Will shift to the right to decrease the pressure by favoring smaller volume of gas. The forward reaction is favored, hence amount of product increases. So yield is going to increase. Okay. Second example. So again, we're going to proceed in the same way. So there's 1 mole here, there is 3 mole here, or 1 particle, 3 particles, so that makes a total of 4 particles of gas. And here on the other side, I have only 2 particles of gas. So again, reactant side is high pressure, product side is low pressure. So what am I doing in that example? So pressure of the system is decreased. So we are decreasing pressure. What will the equilibrium want to do? It will want to oppose it. So it will want to increase the pressure. So how does it increase it? It will shift it to the left. Remember, this is the left hand side and this is the right hand side. So it will shift to the left to increase the pressure by favoring larger volume of gas. Backward reaction is favored, amount of product decreases, yield is going to decrease. Okay, so again, I'm stressing on the fact that pressure applies only when gaseous compounds in a mixture. Solids, liquids, or aqueous compounds are not taken into consideration. So if it is liquid, solid, or aqueous, you see these state symbols, do not include this in your reasoning of what's going to happen if pressure is changed. Okay, so let's look at the next example. I'll work it out. So this is one particle, this is one particle, this is 3 particles, so that makes a total of 4 particles. That makes a total of 1 particle. I'm ignoring hydrogen because it's liquid, so which means that this is low pressure and this is high pressure. So what will happen if we increase the pressure? So the equilibrium will shift. So where will it shift? It will shift to the low side, which is the left hand side. So equilibrium will shift to the left to decrease the pressure, hence the yield is going to decrease. So equilibrium will shift to the left to decrease the pressure by favoring a smaller volume of gas, hence the backward reaction is favored and the yield decreases. If backward is favored, obviously you'll have less product form, so yield is going to decrease. So try this question on your own and then compare your answer to mine in the next video.